the next page because
I can scroll up.
I'm not wasting paper.
Can you scroll up?
Yeah, sure. Let me know when.
Alright, stop.
Alright. Here, I can even do this for a minute.
I got it.
Alright, say when.
Okay, one.
Amy, how you doing?
Set.
Alright. Now, for the graph. Actually, I already need to switch back out to here. Alright. Now let's graph this thing. From your notes, what was my function again? X plus what squared?
X plus 1 squared.
X plus 1, whoops. Squared, x minus 1?
And x minus 3.
And x. Okay, before I hit, use y instead of f of x. Right, picky software. Okay, before I hit this, where do you expect the zeros to be? Actually, you know what? Before I do this,
-1, 1, and 3.
hang on. I'm going to trick you guys a sec.
Don't do
Why?
Well, what's the point of tricking us if you're going to let us know?
I was thinking about that. Hang on. That's true.
That negates
It does.
your intended purpose. You're an
It
idiot.
does. There we go. Hang on a sec.
You are an idiot.
Well, hang on. Relax. Okay, let me see what I can...
Oh, you're not fun.
Oh, perfect.
Oh, look, a blank screen. That's so riveting.
It is riveting, isn't it?
Is it like whatever it is, function F5?
No, that's fine.
No,
No, that was
you did that on
intentional.
purpose.
Yeah. All right, now, yeah, no, this is really exciting. Hang on. And now we go back to... Okay, there it is. I wanted to create a blank screen, but make sure I got the range right. All right, so now, we're going to graph this thing. And I'm going to do it by hand the first time, and then we'll compare it. All right?
You want to embarrass yourself?
Oh, good point. Very good point. All right, where are the zeros on this thing?
-1, 1, and 3.
Negative 1
And 1 and 3.
and 1 and 3. Have I correctly labeled my zeros?
Yeah.
Okay. Where is the y-intercept on this thing?
3.
Positive 3, we said.
Yeah.
All right, so there's that point. Now, what did we say about when one of the terms is squared? What do we say about that?
Bounces off.
Bounces off. It does not pass through the x-axis. Right. There's an even exponent there. That's right, as Kara was gesturing.
I got it.
Okay, good. And what do we know about the other two intercepts? What do we know about the other two?
They just go straight through.
They go straight through. Thank you, Eli. Okay, now, I want to know how far down it goes in between positive 1 and positive 3. I want to know where this relative minimum point is. This minimum one is. So this is where you pull out your calculator. You make sure this graph is in there, and you can put this in factored form. Okay? Let me know when somebody has it in their calculator. This is where you, if necessary, buy a TI-83.
I wasn't here for some of
Friday.
so I know I know what the graph button is. I know what the y equals button is, but what we put into the y equals.
Okay, excellent. Let's see. On this point, what I want you to do, this is the point where you would hit second calc,
Wait, do you want the maximum or the minimum?
Oh, minimum.
minimum.
Okay.
Second calc,
And go to min.
and then go to minimum.
Bella,
Yeah.
when you're fiddling with the window, can you just increase the window by like 1 every time to see how that works?
That could take a while.
take a while.
That could take a while.
So if you increase by 10, would that be better?
Maybe, but if you figure out the minimum first, there's also a zoom fit button under zoom. We'll go over that a little more. But you can figure out the minimum without it having to have the y down there. Once you know how far down this goes, Saul, then you can figure out how far down to make the window. So you can actually do it in a different order. So you go second calc, minimum, and then when it says left bound, which it'll ask for first,
It just show me a graph.
It's showing your graph?
I don't have anything plugged in for y yet.
Okay.
So
Yeah, y equals, who's got the actual equation? Okay, hang on a second.
y equals x plus 1
Squared.
Yeah, okay then.
And then parentheses, yeah.
X
So
plus
then all
1,
that.
then x
Okay.
minus
Since you're looking for a minimum in between two zeros, you can just go ahead and say left bound left bound 1 enter and right bound 3 enter, and it'll give you the minimum in between those two zeros. So left bound 1 enter is what I would do.
Would you ever? Oh wait.
Right bound 3 enter. Yes, Saul?
Would you ever put the left bound -2 1? Negative 2 left bound 1 right bound. Would you ever put that in for anything, or do you have to do that?
-2.
Or -1 1.
Between -1 and 1, we're not going to have a minimum. We're going to have a maximum.
Cause like that's what I got. So like the minimum is that one. The maximum is that one.
Yes.
Oh,
This minimum is 0 because that's on the x-axis because that's where it turns around.
and you'd have 3 things if that one like that line right there like went like that, right?
Yeah, that could happen. That could happen, but not on a 4th degree one. Yeah.
I pressed min. And
Yeah.
It showed me the graph.
Right, and it says left bound, and what it's saying is pick a point to the left of where you think the minimum is.
Oh, alright.
And I'm thinking, since we know the minimum occurs down here between the zeros,
Anything left, okay.
yeah, why not use 1 for your left bound? So you just hit 1, and then hit enter. And then why not use 3, for your right bound. And you see it creates those two little marks above there,
Yeah.
show in between. And then it says guess, and you say sure, it's going to guess for you. And it should give you the coordinates of that minimum. And what does it say the coordinates of that minimum are?
2.3 -9 -10.
Okay, 2.3, -10. I'm going to try and do that by hand here.
I got.
Yeah, I got a different answer. Oh.
Okay, so that's, what did you get? Anyone get a different answer?
Oh,
I didn't round this one.
It's 2.154.
-9.9.
-9. So it's almost, so it's like,